Hello everyone, and welcome all on Data Phoenix webinar. Today we do this webinar together with Hewlett Packard Enterprise, and we will talk about hardware, software, which Hewlett Packard Enterprise have and help you accelerate your generative AI solution. Together with us, Volodymyr Savyak. He is AI and high performance computer sales manager in Hewlett Packard Enterprise, and also Jordan Nanos. He is machine learning architect in HPE. During this webinar, you can ask the question using Slando. The link is under the video, and also we have the widget where you can write your question, and we will happy to answer to this question in the end of presentation. Yeah, and you can join our Discord channel where we can continue this cool discussion, I hope. So I give the microphone to Volodymyr and we can start.
Thank you very much. Good. Let me present. Dmitro, can you load the slide or should you? Okay, thank you. So we already had the introduction, so we skip the slide and go ahead. I wanted to start from short introduction of the company. So I'm not sure if everyone knows about HPE, who we are, but then I need to tell a short story about that. So HPE actually a company which was created like a split of one of the largest IT companies in the world, which was company HP, right? And Hewlett Packard Enterprise is the part of this company which was established as a separate company, which was fully focused on enterprise infrastructures. You can see on this diagram how we evolved with time and which technologies we acquired from the market. SGI, Cray, Mapar, Determined AI, Pachyderm, I guess well-known names for many of you, especially if you are in the business of high-performance computing or in AI at scale. So today, we as Hewlett Packard Enterprise, we have combined teams from SGI, Cray, Determined, Pachyderm, and Mapar. So it's actually incredibly powerful, incredibly knowledgeable team with great experience building the largest machines in the world, building the most advanced AI solutions. And actually, this is why for today, if you take a look who is building the largest machines in the world, not just the largest by amount of servers, but really as supercomputers capable to deliver highest performance for a single application running on top of these supercomputers, so-called capability computers. It's not just set of servers, it's also a combination of specific tools and also a combination of the expertise of the people who can make it run and run a single application on top of it. And we as HPE have this perfect team which combines all this experience and is ready to deliver this experience to you. But this is definitely not just very big machines. We also do something what can be smaller by scale, but very capable in capacity and ability to perform the applications, to run the applications. And what is the reason why people typically buy our solutions? I was trying to understand what is the key advantage, at least on my vision, for you, why you can decide that we are a good supplier for you. And it's not just the best hardware and the best teams, but it's also an approach. It's how we work with the market. It's how we work with our customers. And the idea that we deliver full stack solution. Definitely it's for infrastructure. We are talking about infrastructure, and we are talking today about infrastructure for AI and high performance computing in terms of running large scale models. And we are capable to deliver everything for the infrastructure, starting from the basic hardware and then coming to the middleware and to the software, which is helping you to run your AI and to design and to train and fine tune the models you are building. And this stack up to this, let's say, industry market solutions, which you see at the top of this slide in the presentation, everything below of these industry products is a stack which is based on intellectual property of Hewlett Packard Enterprise. What it gives to you, it gives you a single point of responsibility. When you get a solution with our hardware, with our software, you always know that we as HPE are responsible in front of you for all this stack, and it will run smoothly and reliably. Okay, so what actually is inside of this type of solutions? What we can exactly offer to you? I would like to present you several uh, type of solutions available from us for AI market. We have the solutions which we call GenAI development kit, the kit which consists from single server of different types, some smaller, some larger, some more powerful servers, set of software and services. You will see which exactly software and services are included on the later slides. We also have a solution which is called Hewlett Packard Enterprise Private Cloud AI Enterprise. This is a solution of the, let's say, larger scale. It includes already multiple servers, includes storage, include interconnect, all the network you need to have to connect all these components, but it's also ready to use. It includes all what you need to run your AI, whether it's retrieval augmentation generation or it's inference or it's fine tuning of your model. It all comes pre-configured with the software and services. And we also have large scale solutions, the solutions which are typically purchased either by large enterprises or by cloud providers to deliver services to their customers. I will have one slide about that. You will also be able to see how we do this. Good. So how does this GenAI developer kit is constructed? So what you are getting if you are buying this kit, first of all, definitely it's a compute server. It's server itself, so where your software will run. This is a simple server, Proliant DL380, with this small letter A at the end, which tells you that it's specially optimized for hosting GPUs inside. With this server, and actually this exact combination, with this exact solution, you are getting two NVIDIA GPU L40S. Oh, they can be replaced by L40, which can be important for many countries of our region, because for part of the countries we have limitations to deliver anything which is more powerful than L40, including L40S. So when you go for L40S, and if you are from Kazakhstan or Georgia, you need to get a license from US, and that can take time. We definitely help to prepare all the documents for the licensing, but anyway, it's time, and there is a risk, maybe not big, sometimes big risk, that you will not get the license from US for that. On top of this hardware, you are getting operating system. It will be, in this case, it will be Ubuntu, fully pre-configured with all the drivers you need, ready to use. And then you will have a container runtime. Because it's a single server, we have micro K8s here, so which allows you to orchestrate containers on top of this hardware and operating system you are getting. And the next layer is actually a set of software tools from Hewlett Packard Enterprise to run your AI. So one of these tools is called HPE Machine Learning Data Management. MLDM, which helps you to orchestrate data to build your pipeline. And actually, on top of that, we have here RAG pipeline built in, which you are getting together with this solution. And you are getting HPE machine learning inference server, which is a software which allows you dramatically simplify how you make inference with the models. As an example, you can have NVIDIA NIM additionally if you are buying, NVIDIA AI Enterprise, which is also possible to get from us with this solution. And to deploy NIM, you typically need to spend some time, to pre-configure everything. But with MLIS, you just need to make like 3 clicks, maybe 4 clicks, and you have the model packaged and deployed. It's very easy. It's simple. The next type of solution is actually the same kind of, but slightly larger. It is based on H100. It can potentially be built by H200, but this exact kit is based on H100. What is good with that is that we actually have plenty of them on stock, and we are giving incredibly good price for this type of solution. And with 8 H100 connected with NVLink, you are getting quite a powerful solution with huge GPU memory available for your LLMs. You can actually host something like 384 billion parameters LLM, or with quantization, even something larger. And then you have the same stack of software and also services. Here is the list of services you are getting. So in some countries, these services can be delivered by partners. In some countries can be delivered directly by HPE remotely. There will be setup of the hardware. Actually, we prepare also BIOS for optimal run. We prepare drivers for the network, for the storage. We set up operating system, all the drivers, micro KS, and also our tools to run your AI. And also, as I told before, you will have pre-deployed initial use cases. We actually deliver 2 use cases with this solution. One is RAG, and another is code generation. And these consulting services included actually 40 hours of site remote consultancy job, which helps you immediately run this solution after it is delivered to you. The next solution, which you remember from the first slide, is private cloud AI enterprise, which is the next level, let's say. So it combines multiple components, but it is the same like the previous one in terms of the stack of software services and hardware that you are getting ready to run solution out of the box. So actually it is delivered fully capable to be switched on and run your applications. You can actually work with this setup just after it is delivered and installed by the local team. The important part of this solution is definitely a software and the services. And in terms of the software, it includes components both from HPE and NVIDIA, because actually it is based on the NVIDIA GPUs and networking. And also not only the hardware, but we also add in here NVIDIA AI Enterprise and NVIDIA NIM by default. So you are getting this software in the standard package, in contrast with the previous solutions where NVIDIA AI Enterprise, if you want it, will build something like add-on. Here you also get in HPE AI Essentials and Data Lakehouse, actually, which is based on NVIDIA Emerald software. And definitely all the scope of hardware like servers, storages, rack, everything is combined and ready to use. And you can have it in small, medium, large, and extra large sizes. So depending on these needs you have in terms of the scale or the job you want to do, whether you want to do some inference, or maybe you want to do more larger scale inference, or you want to do fine tuning and maybe you need more resources for that. And just the last slide from my part of the presentation before Jordan starts his own part is about so-called AI factory. So we have a solution which we deliver typically for large-scale enterprise companies and also for cloud providers, where cloud providers can deliver service for their customers. And this large-scale solution, which is called like AI Cloud Platform, AI Cloud Factory, is specific by the usage of the software which allows to make full automation and also multi-tenancy when using all these combined resources, because you can install it, let's say, on the big number of servers and the large storages. There could be secure network, but still you will have some hardware resources shared, and using this additional software which we installing on top of this solution, which is called Morpheus, which is also part of our portfolio, is part of Hewlett Packard Enterprise company. You will be getting functionality for multi-tenancy. And you can actually have three types of services here. It is a service which is like bare metal as a service. You can give a dedicated server to the customer. You can give a dedicated cluster, or you can give part of the virtual machines environment, or you can deliver also the environment which is containerized, actually set of containers or applications in the containers. Good, so that's everything I wanted to present it at the start, and now I pass my word to Jordan Nanos.
All right, hello everyone. So I'm going to continue where Volodymyr left off here and discuss a little bit more detail about the software that he mentioned, which is available for purchase on any system. It does not need to be part of one of the solutions that Volodymyr described, but of course, we have the most experience deploying it on HPE hardware and cloud services. In order to build a machine learning platform, we see that there are three major components. The first is data processing and pipelining for automation. The second is related to model development and optimization, typically referred to as training. And the third is model deployment monitoring, typically referred to as inference. At HPE, we effectively have a platform with an individual piece of software for each of these three aspects. The first on the left is the machine learning data management software, which we originally acquired from the company Pachyderm, who still runs the open source project by the same name. The second in the middle is the machine learning development environment, which we acquired from a company called Determined, which, just like Pachyderm, still has an open source project by the same name. And finally, on the right side, we have a solution that we have developed in the last year called the machine learning inference software, based on an open source framework called Kserve, which makes it easier to deploy and monitor large language models at scale. In combination, these three pieces of software provide the core features that we would expect from a modern machine learning platform, allowing users to prepare their data, train their models, and deploy their models at scale on any Kubernetes cluster. It is important to point out that all three of these software offerings are provided as a Helm chart, which means that you can install them individually if you'd like. I'll go into a little bit more detail on each of these three offerings. The first is machine learning data management. In this interface, which is both a GUI or an API that you can install and build into your existing workflows, it can be thought of as managing machine learning data the way GitHub manages code. Users will have the option to create repositories for their data, which are as scalable as S3 buckets. They will be able to commit to these repositories and track changes with IDs, so that over time, if you would like to refer back to a repository and what it looked like 3 months ago or 6 weeks ago, all you need to do is provide the commit ID into an API call or click on the GUI, and the data will look and feel the way it looked at that time. when that last commit was made. Commit IDs are also tracked through the pipeline process in this software, which behaves very similarly to other pipelines that you might be familiar with from Airflow or Kubeflow or Argo CD workflows. There are many pipelines that kind of mimic the behavior of a cron job and automate the process of doing multiple steps of data processing. The third feature in here is really about parallel processing. Our software provides a Python native method of creating parallel processing jobs. So without needing to learn about technologies like Spark or Ray or Dask, you can write single-threaded Python scripts and then launch them in parallel very simply, either by providing a file system directory, so you launch by directory, or launching by file, or splitting up individual files and launching by those new chunks. In summary, this software provides the functionality in one platform that many users are combining GitHub LFS, Airflow, and Spark to achieve. The next piece of software here is the HPE Machine Learning Development Environment. This is a place to train your models. As you can see on the left side of this diagram, data that comes from the Machine Learning Data Management Platform or from some other data acquisition and preparation pipeline is typically prepared for training. It's split into a train and test set. It's normalized, and it's available for training. What's missing is a way to launch jobs across many GPUs in a cluster, to perform advanced hyperparameter search that doesn't waste resources, to visualize and debug existing experiments that are running, to checkpoint training jobs in the middle of them and resume them potentially on different GPUs, to register models that are trained in a place where you can track things, host notebooks and allow users to collaborate, generally speaking, and do much more. This platform provides all of those features, and it runs on any underlying GPU. We support NVIDIA and AMD GPUs today, TPUs in the cloud, as well as CPUs for existing HPC clusters running Slurm or PBS. All of that is supported. We also have recently launched a lot of work related to large language models, where you can simply run fine-tuning jobs through the Hugging Face Trainer API, integrated right into this platform, and you get all of the benefits of using our API on top of that, as I just described: checkpointing, distributed training, visualization, things like that. So if you imagine that we started the process by saying that we can manage data and prepare it for training, possibly processing medical claims or processing large repositories of emails or product documentation, getting it to the point where we can fine-tune a model to perform some downstream task that we care about, like classify the medical documents or summarize the emails. We can then take the fine-tuned model and deploy it in the third software as an API, as an inference service. Of course, we don't require only fine-tuned models from MLDE to be deployed here. We can also pull any model from Hugging Face, any NIM from NVIDIA NGC, or we can package custom models and then bring them to this machine learning inference software for deployment at scale. We see that many users today are seeing the limitations of running a single model in a single Docker container, seeing it get popular across the organization, and then trying to scale up their web application so that you can have many users. This is a framework that puts an API endpoint in front of every model and allows us to auto-scale and load balance across many GPUs, increasing throughput at enterprise scale. It also provides easy ways to implement metrics and logging services outside of the individual models that you are actually deploying onto the platform. In order to better describe this software, I'd like to jump and do a quick demonstration of it and basically demonstrate that HPE's AI solutions support everything you may want to do with large language models, from full training to fine-tuning to RAG to prompt engineering and finally to serving. On screen here, I've pulled up Open Web UI, which is a simple way of getting started with chatting with models. And you can see I have a quick access to a model assistant. This model is relatively high performance. It's printing things out pretty quickly and giving me relevant responses. One thing that I want to do to demonstrate this is to copy an email thread and so a quick summarization application. I was talking to Vladimir earlier about some work that we're doing with a customer, and I'm not sure I want to read that entire email thread. Very quickly on screen, you'll see a quick summary of this email thread so that I can understand, hey, Vladimir is asking me to test the Llama 3.1 405B model on one of our new DL384G8 Gen 12 servers using 2 of the Grace Hopper super chips. This is quite a simple demonstration to show a summary of an email thread. And I wanted to do it to show you that it is powered by an API endpoint that is available to anybody in the organization. It's also fully private. So I have full confidence that any data that I upload in there is not being tracked by a counterparty hosting a model on a public endpoint. It's running on a server that I fully control. Specifically, it's running on this cluster that uses the HPE machine learning inference software. Amongst all of my peers, we have many different model endpoints. Specifically for that demonstration, I was using the Llama 3.1 8B instruct model endpoint that I have configured to be fixed to just one instance or one GPU. However, I also host a copy of the 7DB model, and I also host a copy of one of the latest models released by NVIDIA, Nemotron. I'd like to jump back here, start a new chat, and show you a little bit of the difference in using some of these models. I'll go for a blog post about GPU performance. One of the things that many of our users want to control is the speed and the performance of their models. You can see on screen here that the first response I got from the 8 billion parameter model was very quick, many tokens per second, upwards of 50. The second one is still going. However, the second one from Nemotron, we know is a higher quality output because that is a larger model. So in this case, we see there's a trade-off, selecting sometimes a smaller model for a quick response and a quick summary, and sometimes selecting a larger model for a higher quality response that may take a little bit longer. With the HPE machine learning inference software, you have the ability to quickly test different models on different GPU resources. This Nemotron model uses 2 GPUs in my cluster to get that sort of throughput. Meanwhile, the 8 billion parameter model is only using 1 GPU. These are the sorts of things that I can control and configure when I'm starting model endpoints. I'd also like to show you that this is not restricted just to this interface here. I can flip over and show a different application, specifically write in VS Code, that lets me get a very similar experience selecting from these same model endpoints. Write a program to perform bubble sort in C. That looks pretty good. Add comments for explainability, readability. Block by block, I can accept certain comments. I'll accept them all. It looks pretty good. What is the bubble sort algorithm? This is the exact same model endpoint that's printing out these responses and generating this code as the model endpoint that I was using to power two experiences in two separate interfaces, both of which are calling this URL, which I can access a docs page here. And powered by Kserve on top of our Kubernetes cluster, we can effectively create many different model endpoints, A/B test models behind this endpoint, auto scale up and down as more users log in for the day or log out. Really, it's a very powerful way to drive what we would consider as a private AI experience. In summary, I'd like to wrap with a single slide. Why would you consider HPE for generative AI? In a word, our private AI services provide users with control over their AI applications. We allow you to control the data that you're using with guarantees around privacy and security that come natively from running infrastructure in a private environment, your data center, your colocation. We let you comply with local regulations and have protection over your intellectual property and any copyright issues that may be exposed by uploading data to third parties that you don't trust on the public internet. The second aspect of control is over model performance. This can be characterized in terms of speed and in terms of quality. In terms of speed, we can allow you to improve throughput by deploying models across multiple GPUs, in changing the runtime over time, quantizing the models, or to reduce latency by controlling which hardware this model actually runs on. The balance of speed with performance I demonstrated briefly. We also allow you to fine-tune models to improve their quality, improve performance against some metric or some benchmark that you care about. This means that you have full control over the model weights that you are using, whether you're building from open source models like Llama or Mistral, or you've trained something from scratch. We don't restrict what you can deploy within the platform. And you can also integrate your private data sets to power retrieval augmented generation pipelines, text to SQL experiences without taking on any risk of uploading them or giving them to some third party. The final aspect of control is control over your costs. Because this is a private AI service that you operate or you partner with us to operate for you, there's no surprise bills for data egress, for bursting during busy times to spot instances. We also don't charge per token or per user for licensing that grows over time as more people use the platform. Instead, we typically provide a set level of capacity that matches the needs for you to build a pilot and scale to production with an emphasis on best of breed open source tools instead of locking you into proprietary software. So that's all that I have for my section of the presentation. I want to say thank you. If you'd like to reach out, my email is on screen. I'd also welcome anybody who wants to watch some more of these demo videos to check out my YouTube channel. It's Jordan Nanos on YouTube. Reach out on LinkedIn. But I think now we're going to take some questions from the audience.
Yep. There are some questions. Dmitro, you are muted.
Yeah.
Yeah.
We have some questions, and also I have some questions to discuss. we know that HPE very often associated with very big customers, but I know that you also help some startups to grow it, and they also can collaborate with you and get some benefits. So maybe you can provide some more details in this way, how you can be useful for startups, how they can get software or hardware.
Okay, let me start with that. So first of all, there could be several levels of cooperation. So one is very simple. We sell, you buy. Yeah, it can be something simple like you saw on my slides. It's not only big machines. Yeah, from one side, yeah, we are proud that we are building the fastest machines in the world, but it doesn't prohibit us to sell a single server with a set of software and applications on top. And actually, we have quite special discounts on that kit, which is called development AI development kit, which you saw on my slides. That's the first point, which is simple and easy to understand. The other part is that we as company, being quite a big company working with many customers, especially in the smaller countries, like the countries of our region that we are making now our presentations to, we don't have ability to do everything ourselves. Yeah, we are heavily dependent on our partners. And who are our partners? First of all, it can be any company which complies some rules and limitation we are asking for our customers to comply. It starts from some ability to deliver the solution. So you should be certified, you should pass some certifications which have different levels. Yeah, you can start from something simple, you can go for something more advanced. If you do it more advanced, you are getting additional discounts. We have specific bonuses for top level partners. And when you become a partner and when you can deliver some solution, typically we are talking about some solutions on top of our infrastructures, including our software infrastructure. But this is not what typically customers need. Our customers usually need an application and need integration into their environment, which requires often a job of the partners locally. So if you are a startup or a system integration or a seller company, and you see yourself on this market, you can come to us to become our partner. You can learn our software, our hardware, and you can deliver together with us. Yeah, you will have support from our brand, support from our people, from our system. And if you do something special, which is very interesting, advanced, and can be interested for wider market, we often invite our partners to specific collaboration projects. We can fund your market in different ways. Like we have a special MDF, Marketing Development Fund, which we invest into our partners, which helps them to develop their business. For sure, you will have more MDF if you make more business with us. That's obvious, right? But that's just an example how it can be done. Some companies go further. So if you can deliver some solution which becomes interesting to HPE will be happy to acquire a company and you will earn, a lot of money. But like it happened with Pachyderm, like it happened with Determined AI, that's a good examples. Some companies becomes part of our ecosystem. We have a specific partner ecosystem when we, as HPE, resell the products of different companies worldwide. As an example, when building, a solution of this level for cloud providers, we are including their OpenShift from Red Hat. That's one piece of component. Another piece of component, we are including Morpheus. Morpheus was recently independent company, just acquired by HPE, but actually we were reselling Morpheus in our solutions because we needed something which will allow us to build this type of solutions. So these are just some examples how you can cooperate with us.
Uh, cool, yeah. Thank you for this answer. Second question's more technical, maybe. Today, very often companies host their solution in the cloud. but some part of the solution they try to host locally. Depends on some private policy or other. Um, so, what is from your side as a company which, first of all, built local clusters on some private cloud, how to better design the architecture and on which bottlenecks companies should watch first when they do design and plan the scaling when they use some hybrid infrastructure, some part in the cloud and some part locally. And locally, it's very often for now deployed some models because it's I think more cheaper to have your own hardware with GPU that rent it in the cloud.
Yeah, it's certainly cheaper if you have, a consistent workload over time. I think we've seen lots of people build hybrid where you can burst to cloud services at busy times, either because people are submitting more training jobs or because you need an extra amount of throughput for the model endpoint. I think the biggest thing with an architecture to consider that we see people running into at scale is how to support many concurrent users for inference. Um, Currently, I think a lot of people are limited in the throughput that a single GPU or a few GPUs in a single server can provide. And even though technology exists to do auto scaling and load balancing on Kubernetes, not a lot of people in machine learning want to learn about Kubernetes for the first time just to scale up a inference service. So the first thing is just the skill set to be able to deploy models on Kubernetes and then build a Kubernetes cluster with enough GPUs that you can auto scale up and improve throughput. In the example of a coding assistant that I saw recently, we were working with a company who's large, but started like a startup. So they started by testing with about 10 developers. And very quickly, the developers liked the experience, and the same, system with the same GPUs could scale up to about 100 developers, depending on how busy it was. But this organization had almost 20,000 developers total. And so they weren't prepared to scale that large without bringing in a lot more infrastructure and starting to think about building a Kubernetes cluster with a high performance network and high performance storage to support things at that scale. So, I mean, we can help with the software side and with the infrastructure side, but it takes some skill set, some preparation on the administration team's side to be prepared to scale to that large of a cluster.
Yeah, in terms of using hybrid, actually, our tools also allows you one or another way to go hybrid. Some less flexible, some more flexible, but actually MLDE, which is machine learning development environment, which is determined AI on open source version, allows you to use different pools of GPU resources. You can actually have at the same tool, you can have resource which is local, and on another pool, you can have resource which is external, if it is set up the right way. And then you can use one or another pool. So maybe it's not like bursting, but it's different resources which you can use by need, right? So while you have some local resource available, you'll use local resource. If it's finished, you go for your external resource, you pay extra money, but maybe you do this not very often. And this kind you do a kind of manual burst. And Morpheus, which is part of this larger solution, yeah, you can do it at smaller scale. I recently made a solution for the company which required just 4 servers. Okay, so every server with 64 cores, but 4 servers, and on top they have Morpheus installed. planned to be installed, and they will be able to connect to Morpheus also different resources. It's also a platform which allows you to combine internal and external resources, and actually of different type. It can be bare metal, it can be virtual machine, it can be containerized. And when talking about the design of solutions and about bottlenecks, that's a topic to start. Maybe we need half a day at least to touch the surface. Yeah, but actually, what I'm seeing on the most issues I'm seeing on the deployment which are made by customers team without experience of having this wider range of installations like we do, and our experience of our team, the most of the issues I see on storage side, maybe that's just occasionally, I don't know if that happened to me, but it looks like many people just don't understand how the storage will influence what they do. But as I told, maybe it just happened to me, but everyone else does. It's very nice.
Yeah. Uh, um, Continue the topic about design and Jordan, you showed today how to chat with um, LLM in your software, but
Mhm.
you put the data in the chat. But the organization very often not do this. They have some databases and they need to connect their information to the new system if they buy it. How this process work? How they can start to chat, for example, with their data, and what database, some source
Yeah.
of data you support?
Yeah. So I didn't really have time to do the demonstration on the webinar today, but I have lots of recordings of me chatting with databases or documents on my YouTube channel. If you want to check them out, the videos are there. Or you can reach out directly. We can schedule a call for a time to go through that. I think the concept of chatting with your private data is a pipeline, which is to say that we are adding some sort of extra logic either before the prompt gets sent to the large language model or after it gets returned. And in some cases, we're actually doing multiple turns. So you may be in one request from a user, one question input, you may be using multiple models. So in terms of using an organization's, proprietary data, there's two big workflows. One is for structured data with a database, and the other is for unstructured data with documents. The first I would call text to SQL, and the second I would call RAG, or retrieval augmented generation. So text to SQL is relatively straightforward because what you really just need to do is connect to the database and then have the prompt of the large language model be designed in a way where it will convert the user's natural language question into a SQL query, return the results, and then you can either have the large language model prompted again to synthesize the results if the query output is very large, or you can just have the raw output displayed on screen for the user. In my demo online, I ask a question of a restaurant review database. What are the top 5 restaurants in this city? It converts it to a SQL query. It sends the response back in raw format, which is just a whole bunch of reviews. And then I use a different language model endpoint to summarize those reviews and write a blog post. It's a relatively straightforward way of integrating with the database in a few different steps. RAG, the other one, is typically for unstructured documents, so PDFs, text files, the email I showed during the demonstration. In this case, the data is split into chunks. It's run through an embedding model, which is a second kind of language model you might use, and then only relevant chunks are retrieved when a user's question comes in. So what's the latest on this product document, on this new product that HPE is launching, the DL384 Gen 12? Before we publish those quick specs online and before they're picked up in LLM training runs, we may be able to just add a PDF about the DL384 Gen 12, ask a question, which GPUs does it support, it goes and finds the relevant chunk from within the document and answers the question. So two separate workflows, but fundamentally, when I was showing that interface and I was switching between different model endpoints, the user experience is that you just select which of the certain pipelines or which of the certain functions you want to run. Chat directly with the model, do a text to SQL thing with a database, do a text to SQL with a different database, do a retrieval augmented generation with a set of documents, do RAG with a different set of documents. Those would just be selections on a menu. And then the development team is actually controlling the logic behind the scenes, what the prompt says, what database it connects to, that sort of thing.
Okay, so there was a question about the size of the data set you can handle with Pachyderm, right?
Yeah, I only want to ask this question. We have the question from our audience about using Pachyderm and the problem with dataset more than 30 gigabyte of dataset for images, as I understand. So
Yes.
they come back to use DVC.
Yes. Yeah. So Pachyderm is tested at the scale of S3 storage, which is to say dozens of petabytes and billions of files. It is incredibly scalable. It's tested by some of the largest organizations working on drug discovery, autonomous vehicles. These are very large data sets in terms of single files being hundreds of gigabytes or even terabytes in size for gene sequences and for HD video, as well as for other use cases where you have many small files, billions of files on the Pachyderm system. Pachyderm is fundamentally a application that runs on top of S3 and provides the versioning and pipelining I was describing. So it's as scalable as S3 is in terms of data storage.
Yeah. And we actually have implemented this S3 storages really for petabytes, yeah, like Jordan says.
Yeah.
Yeah.
It's not restricted to only run on object storage with S3. It can run on file systems, but we're going to build an erasure-coded object store to do deduplication of data if we're provided a file system as the raw place to store the data. So it scales very large, is the summary.
And other question about the price of ML platform. What is the price of this platform? And it's really that company don't need to have ML ops for this platform if they will use it.
Yeah, I probably can
I
show at least on
wouldn't.
Gen AI dev kits, actually for HPE, the topic of price is quite sensitive in terms of the markets because we have a lot of local representative offices which can have their own policy which can slightly change the price, not dramatically, but there are always some different taxes locally which influences and there are different investments locally which also can somehow influence on limitation with local margins which can be applied. So it's difficult to answer precisely, but to understand the level of pricing, we have this indication on our presentation for this Gen AI development kit, and you can see it on the slides. Dmitro, if you can show this slide number 4 or 5 from the presentation, don't know how to make it now active. Not this one. Yeah, let's do this. Okay, you can see here that this solution, which includes fully functioning server, which has a lot of software, including these commercial versions of Pachyderm, which is machine learning data management, which has machine learning inference server, which is also not a cheap piece of solution. So all of this, including 40 hours of professional consulting included, which is also not cheap part, it is is somewhere from 150K, but it's without taxes for sure. Yeah, it's preliminary pre-approved price. Yeah.
Yeah, and just a comment about how this scales. To be clear, and roughly speaking, the price goes up with the number of GPUs, right? So if you have more GPUs in a cluster, you'll pay a larger price for the software. If you have less GPUs in the cluster, you pay a smaller price. Dimitri, I think I heard a comment about replacing MLOps, and I don't know if I made it seem that way, but we certainly don't expect to replace MLOps engineers with software. We expect that the work they will be doing will be easier and more productive by using the software. But
but
none of
not
this
not
is easy
not
enough to say we have no more MLOps engineers. I don't know if that was what you said, but
Yeah, it's real because when we have some system, ML system, we need always to admin it to change something in pipelines, to upgrade, to improve, and so on. And this part on MLOps engineers. Yeah, so in any case, you need to have MLOps engineers. Also, one question about the platform. You show all, but you not show some observability and some monitoring for ML models. What functionality in this part you have?
yeah, well, uh, good question. Let me pull it up. Can you show my screen quickly, Dimitri? Uh, so I was showing these model endpoints for every one of the model dashboard, which you can pop open, and it's a Grafana dashboard that shows, for example, the number of successful requests to the model in the past 5 minutes, the number of requests per second, any failures. And in this case, I'm tracking the service logs from the, in this case, the VLLM runtime. So you can see, for example, the throughput that's actually being, achieved. But there are many sort of configurable options here to monitor the logs of what's actually coming into the model endpoint. I was doing a demonstration for privacy, so I basically turned off one of these functions here, but we could have the full request and response for a given logging infrastructure if you'd like to monitor what users are doing, or you'd like to take the user requests and build a fine-tuning data set for them or something like that. So it's Grafana. It's a endpoint like any other logging infrastructure. You're just now monitoring,
Yeah,
in this
cool.
case, the
Y-
Llama 3.17 DB model, for example.
yeah, and maybe one of the last question. Today, the hardware market is changed when the AI is start growing because very often we need to more powerful machine, we need more powerful GPU. So as company which build the largest systems, how you see the future of hardware? What comes new in this area?
That's a big question, and I do a
Another half a day.
I do a weekly podcast with a friend, Hunter, on my team. I think we kind of talk about this every week about what's changing with hardware. So I don't know if I can summarize that quickly. I'll give it a try. The biggest thing that we've seen is accelerator diversity. So when I started working in AI 8 years ago, The answer was NVIDIA, and what was the question? We now have large language models that are frontier class trained on AMD MI300 GPUs. As you can see with Llama 3.1405B, only working on AMD GPUs for the native format, FP16 for inference. We also have Gemini from Google that was trained on TPU. We've got Anthropic training on the Trainium silicon from AWS. We've got startups like Cerebras looking to go public. Grok making noise with incredible throughput for the Llama endpoints. There's just Intel's Gaudi 3 GPU is coming soon, originally from Habana. That's a very exciting thing. So I think the biggest thing we're contending with for the future of hardware is being able to support a diversity of accelerators in a single cluster so that users can pick the right accelerator for the workload that they have, instead of building one cluster all with the entire thing being this exact same ratio of CPU to GPU and expecting all workloads to fit on that exact ratio. There's going to be workloads that need more memory bandwidth, that need more compute, that need a faster interconnect, that need great access to storage. And we need to be able to tune the system based on the workload as opposed to making everybody use the same NVIDIA GPUs.
Yeah, I fully agree. That's and actually, if you're a big cloud provider, you also will need to go for energy business.
Yeah, it's a very interesting part of any system, I think. Um, yeah,
Good.
good. I think we are done for today. Thank you, Jordan. Thank you, Aldimar, for this interesting presentation and overview of solution which Hewlett Packard Enterprise have. And I hope we can continue the discussion after the, after we publish this video in our Discord channel or on our YouTube. Yeah.
Thanks
Thank
for
you for
hosting.
all.
Thank you very much.
Yeah.
That was nice. Yeah.
Thank you for all, and see you on the next webinars.
Bye bye.